Okay, what we're going to do first is the non-ruminant enterocyte. And so to begin on the bottom of the basolateral membrane, we'll put the sodium-potassium pump. Pumping 3 sodiums out, 2 potassiums in. Do this at the expense of ATP. And then just to keep track of our sodium concentrations, we'll have high sodium concentration out there in the blood, low concentration of sodium inside the cell, and then high concentration of sodium outside the cell. First thing we can do is put in the SGLT1. And SGLT1 can, remember, go against the concentration gradient, and we're going to bring in a sodium. It's going against the concentration gradient for the carbohydrates with the concentration gradient for the sodium, so against the concentration gradient for galactose or glucose, but with the concentration gradient for sodium. Okay. Next, we'll put GLUT5. 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 5 starts with F. And that helps us remember that it's going to transport fructose into the cell, and that has to go with the concentration gradient. Okay, then on the basolateral membrane, we'll put GLUT2. GLUT2. And GLUT2 is going to transport with the concentration gradient glucose, galactose, or fructose. And in the fasted animal, so we use dashes. Write the word fasted. Glucose is going to be transported into the enterocyte because the concentration of glucose when the animal is fasting is going to be greater in the blood than it is in the enterocyte. So it's going to move back into the blood, or back into the enterocyte. If we have high, really high, very high, GLUT2 can move, and that will allow the movement of glucose, galactose, or fructose. And then I think in class we put a box around this so we remember that it only occurs at specific times. And that's basically when glucose concentration is high, comma, really high. And the other one could be when you have artificial sweeteners, but generally it's just when glucose is high, really, really high, because we don't feed a lot of artificial sweeteners to animals. Okay, we haven't done this in class, but we'll talk about it, hopefully. This would be the ruminant enterocyte. Okay, so the ruminant enterocyte, the same thing is going to happen on the basolateral membrane, in that we have the sodium-potassium pump. I did that backwards, but we can adapt because we're adaptable people. And so that's happening at the expense of an ATP, creates a charge. We have high sodium concentration out here, low sodium concentration in there, and high sodium concentration out here. Okay, everybody should be good on that. So this one's going to be relatively simple. Only transporter we're really going to have is SGLT1 up here. And SGLT1's only going to bring in one sugar in the adult rumen animal, and that is glucose, and it does that with a sodium. Okay, and we're not going to draw these other transporters because there's no fructose in the small intestine of the ruminant animal, because all the sucrose is going to be degraded and fermented in the rumen, so we don't have to worry about absorbing fructose. And we're not going to achieve really high glucose concentrations, so we don't really have to worry about this. Okay, so it's not going to happen. GLUT5 is not going to be important because there's no fructose to absorb. And the only time we're going to absorb anything other than glucose is when the ruminant is nursing, and then we'd absorb galactose, right? Something else you might want to draw on here, just so you remember, would be GLUT2 down here on the basolateral membrane. And GLUT2 takes glucose out. When the animal is fed, we're absorbing glucose. And when the animal is fasting, it's going to bring glucose into the cell. Okay, so you might really want to look at the differences, and that might be useful as you guys write your papers, to look at the differences in those enterocytes. And just remember, no fructose in the ruminant animal because they're not digesting sucrose in the small intestine, and we don't have really high glucose concentrations because not that much starch is going to make it to the ruminant enterocyte. So otherwise, you should be good.